Now, anytime you're asked to create a polyfill, which would most likely be during interviews, you should obviously know what the original feature does. So say you're asked to write a polyfill for the array method reduce, you should know what the method truly does, how it does it, what will it take as parameters, what will the function return, essentially everything related to that API. Once you know the fundamentals, then it's just a matter of covering individual cases step by step till you feel like you're satisfied with the solution. So let's look at the first array method, which is the map method. Now this map method is pretty straightforward. You iterate over an array, run a function on each item of that array, and return a new array with those modified items. So what I'll do is I'll create a new function. Since we want all the arrays that we'll create moving forward to run this custom map method, we'll have to attach this polyfill method on the array prototype. Think of a JavaScript prototype as a template. When you create an object in JavaScript, there's an object prototype that's referred. This prototype has certain keys and methods that you can use. So inside the browser console, I'll log the array.prototype. You'll see all the array methods and properties that you can run on any array. And we want our custom map method to also be in here. So what I'll do is I'll simply use array.prototype.custom_map, and it's going to be a function which takes in a callback. So just like your typical map method, this will take a callback, and this callback is going to run for each element that we have inside the array. Now if I save this and go back to the browser, now if I try to log array.prototype, you should see the custom map method as well. Yeah, you can see it here at the top. We'll do the same thing with the custom filter and custom reduce polyfills later in this video. Now inside the method, we'll first create an empty array that will hold the result of the callback function for each item from the original array. I'll run a traditional for loop on the array, and you can get the array instance by using the this keyword. So anytime I try to run the map method on an array, anything that's before the dot is what's going to be the this keyword. So if we want to access the array on which this custom map method is going to run, we can simply use the this keyword. Inside the loop, all I need to do is run the callback for each element and place it on the same index inside the result array. Now all I have to do is return the result array outside the for loop, and we are good to go. I'll create an array at the bottom here to test this out. So we have an array of numbers here, and all I'm doing is squaring each number. You can see that we get an array of numbers here, and if you take a look at these numbers, they are the squares of the numbers that we have in this original array. So our map method works as expected. Now one minor edge case would be to check if the original array elements are valid or not. So say I add an element on the 10th index of this array. Now since the original array will have undefined blocks in the middle, so from index 5 to index 10, you can see that we have these undefined elements. When I try squaring undefined, it will give me not a number as the output, and it will consume unnecessary space in the array, which is not how the original map method behaves. So if I go back in the browser, you'll see that we have all these nan elements. And if I copy this and just create a map variant, the native map method. Now if I console log this array as well, you'll see that we do not have these nan values in the result that we get from the native map method. So that is what we should also try to achieve in our polyfill. So to check the validity of a number or any item in the array, I'll simply check if it's not undefined. If that's the case, we'll add the item on its designated index in the final array. So I'll put this inside an if block, and I'll check if it's not undefined. Only if it's not undefined, put it inside this result array, or else just skip it. So now if I go back, you'll see that we get the same result as we get in the native map method. Now if you again go to this map method's documentation, you'll notice a second parameter, which is the this argument. It lets you set the value of this for the callback function that you'd want to run. I've never really come across a use case for this, but we'll add it in our polyfill anyway. I'll add a second argument to the function, and instead of calling the callback directly, I'll use the call method that lets you call a function with a specific context. So inside the call method, I'll pass the this argument, and that should do it. If I go back to the browser, you see that the response is still the same. There's no change here. You'll come across a few other edge cases as well. Like for instance, the callback method that we pass inside our polyfill. This callback method might not even be a function. That can be an edge case. You can handle that by passing in a check at the top to see if the type of the callback is a function or not. But that's something that you can handle yourself. This is the meat of the polyfill. So for the most part, the interviewer should be happy with this solution. Now the filter polyfill will also have a few similar elements. The way it works is, again, it will iterate through an array. The callback function is supposed to return a Boolean value this time. If it's true, we include the element in the final array, or else we skip it. So I'll again attach the custom filter method to the array prototype. Let me comment these out for now. I'll create the result array and I'll also return it at the end. The for loop iterates through the original array. All we do inside this loop is check whether the callback function for the current element returns true or not. If yes, we push the current element to the result array, else we move to the next index in that iteration. You'll notice this pattern here again from this custom map method. We first pass in this argument, then we pass in the element, then we pass in the index, and then we pass in the array on which this custom filter method runs. So yeah, let me create some new examples here. So let's go back to the browser and see if this works. Yeah, you can see that we get the even set of numbers first and the odd numbers in the second console log statement. In this case, even if I add an element at a random index, the undefined elements will always return false inside the callback function. So you'll always get the expected array. So basically I don't have to use this check that we had in the custom map method inside this polyfill. But I'll still add it because then it won't even go inside this if block and run this callback function. If an element is undefined, we just go to the next iteration right away. So right before this, I'll add a check to see whether if it's not undefined. If I go back, you should see that we have the same result. And say if I add a number at a random index, you should still get the filtered result without any empty values in the array. And we finally come to the reduce polyfill, which might be a little tricky. So the intention behind the reduce method is to reduce an array to a single value. So we iterate over the array, and on each step, we perform the callback function on each element, passing the returned value from the calculation to the next element. And hence, at the end, you'd be left with a single value. Now there are a few elements specific to this method. The first one is the initial value. So as I mentioned, the returned value from each calculation is passed to the next item, but there's no value that can be passed to the first element in the array. So we have an option to provide an initial value. This is optional though, so if you do not pass in anything, the initial value defaults to the first item of the array. If the array is empty, then an error gets thrown. The next item is the accumulator. So this is the result from the calculation on each item. So for the first call, it will either be the initial value if it's provided, or the first element of the array if the initial value is not provided explicitly. There's this reducer function, which is just another term for the callback function. And yeah, that's all you need to know about this method. Now let's try to build a polyfill around it. The initial structure would be the same. We attach the method to the prototype. This function though does not have an option to pass in this argument. Instead, it takes in the initial value. Inside the function, we'll again run the for loop. At the top of the for loop, I'll create the result variable. And since in this case, it's the accumulator that acts as the result, I'll call it accumulator. At the bottom, I'll also return this accumulator. Now I first need to check if there is a starting value. If yes, then we'll set it to the accumulator, or we'll set it to undefined. Now the reason why I'm doing this is because if I directly set the first element of the array to this accumulator here, then I need to conditionally skip that element inside the for loop. Now I can simply check if the accumulator is undefined or not inside this loop. If it is undefined, that means we do not have an initial value, so I can set it to the first element of the array. Now if it's not undefined, this means that there is an initial value, or it's just at a later stage in the execution, so I can directly run the reducer function on that accumulator. So that's what I'll do. I'll first check if I have a valid accumulator. If the accumulator is invalid, which means that we are at the first iteration of this for loop, then I'll set it to the first element, which is this dot 0. Now we come to the final part, which is to store the result of the operation in the accumulator. This is what's different from the map and the filter methods. In both of these methods, you only pass the current element inside the callback function. In this case though, since you also want the next iteration to know what's the value of the accumulator, you need to pass that as well. So you can pass in the accumulator as the first parameter and the current value as the second parameter. The rest two are just like the map and the filter methods. These are optional parameters, the index and the array on which the reduce is being called. Now let's create an array where we can sum up all the items in that array using this custom reduce method. So I'll get rid of all this here and let's remove some of these elements. When you run this custom reduce function on this array, the function expects the callback and the initial value. So let me create a variable first, and this will run the custom reduce function. It takes in the callback and the initial value. I pass the initial value to 0, but if I skip it, it will use 1 as the initial value from this array. So the first element from this array. Now the callback function takes in two parameters, the accumulator and the current value. And all I'll do is add both of these values and return the sum. So I'll convert this callback into a function that takes in an accumulator and a current value. And what it's going to return is the sum of both of these values. So basically in the first iteration, you have the accumulator coming from this initial value, which is 0. And the current value is going to be the first element of this array, which is 1. So the sum of 1 plus 0 is going to be 1. This is passed to the second iteration, where this time the accumulator is 1 and the current element is 2. So 2 plus 1 is 3. For the next iteration, we have 3 here and current value is going to be 3. So 6 and so on. At the end, all the items are added and you get the final value of the accumulator, which is 15. Let me actually console log this over here. And if I go back to the browser, I get an error. Let me change this to numbers. Index is not defined. Let me see. Oops, I've used index here instead of I. Now if I go back, you should see the 15, which is basically the sum of all these elements from this array. So yeah, those were the 3 array method polyfills that you'd normally be asked in interviews. Try to come up with edge cases and incorporate them in these polyfills. As a bonus assignment, you can try out a polyfill for the for each array method. It's again similar to the map method polyfill. The only difference here would be to not return a new array. So yeah, give it a shot. Also do subscribe to the channel for such similar content, and I'll see you in the next one.